Hey guys, Mr. Ray here. We're going to continue on with our exponential and logarithm units. We're going to get into solving exponential equations. Um, in this very short lesson, we're going to be talking about changing the base so that we're able to solve equations. So it's a pretty limited lesson, and we'll have two more lessons after this that are also quite short on other techniques of solving exponential and log equations. It's pretty much interchangeable, the exponential and logarithmic equations. In a lot of cases, we're going to end up changing from one form to the other to be able to solve it. So this is called exponential equations, but we're going to use some log tools as well. Okay, so like I said, it's going to be mainly using the technique of changing the base. So this first example is really, it's not solving equations, but it's just practicing changing the base. So we want to change each of these into a number that's a base 2, so 2 to a power of something. Okay, so we'll start off with something fairly straightforward. We want this to be 2 to a power, and 8 is a power of 2 already. So 2 cubed is equal to 8, so that's fairly straightforward. Okay, here we have 4 cubed, so that's not a power of 2, obviously, but I can change the base to become a power of 2. So I'm going to basically, I'll keep it the same. I'll keep the cube exponent out here, and I'm going to change the base to a power of 2. So, so 4 is equal to 2 squared. Okay, and now at this point we're going to use the power exponent power of a power rule. So when we see something like that, two powers together, we multiply them together, so we get 2 to the power 6. Okay, and this can be easily checked. You can, on your calculator, you've got the y to the x button, or x to the y. You can evaluate 4 cubed, you can evaluate 2 to the power 6, and you should see that it's the same thing. This one looks a little bit scarier just because it's got lots of powers and radicals, but it comes down to the same thing. So first thing I'm going to do before I worry about the base is I'm going to change the radicals signs into exponents. So as you remember, square root is equivalent to having an exponent of 1/2. So I'm going to put 16 to the power of 1/2. That's the same as the square root of 16. Multiply that. I'm going to start with the 32, which is under the radical. Now this one's a little bit more complicated. It's got a 5 there. That means it's the 5th root. Okay, so that by itself would be to the power of 1/2. Sorry, 1 over 5. But we also have it being cubed, so that basically would go at the top of the rational exponent, so that would be 3/5. So hopefully you remember converting something like that into a rational exponent. So now we've got 32 to the 3/5 instead of that. So now the next step, we're going to change the bases to a power of 2, and you can see that both at 16 and 32 are powers of 2. So 16 is the same as 2 to the power of 4. So I'll put that inside the bracket, keep that 1/2 out here. And 32 I can rewrite as 2 to the power of 5. And then I still have the 3/5 out here. And now in both cases, we're going to use our power of a power rule, multiply the two exponents to get our combined exponents. So 4 times 1/2, that's equal to 2, so that's 2 squared. Okay, and 5 times 3/5, well, that works out nicely because the 5's cancel, and I get 2 cubed. And now this looks a lot more normal. This is just using regular exponent rules now, so this is the product rule, multiplying two powers, the same base. We end up adding the two exponents, not multiplying, so this would be 2 to the power of 5. So that simplifies quite nicely from something that looks intimidating to something that doesn't look all that bad. Okay, this is where it gets a little strange. so far all the bases we were starting from I could convert them into powers of 2 quite nicely, but now we've got 12. So the goal here is to write it as 2 to a power of x. We don't know what that x is, but 12 is not, I can't, there's no integer exponents that are going to work for this. 2 cubed would be 8, and 2 to the 4th would be 16. So we know it's somewhere between 3 and 4, but, how do we actually solve that? And the answer to that is using logarithms. So what we're going to do is rewrite this in the form of a logarithm. Okay, so you can, if I was to name these parts, I'd say that's the base, that's the exponent, and that's the result. Okay, so when I write it as a log, I'm solving for the exponents because a log is an exponent. Okay, so I always start off with the exponent is equal to, and then the log. But I need to know the base of this log. The base of the log is the same as the base of the exponential part up here. So it's log base 2 of 12. Okay, now some calculators have the ability to evaluate this. You can enter the base, you can enter the result here and get your answer. Most calculators don't have that ability. Most calculators only do log base 10, which is common log, and ln, which is the using the base e. Okay, so the way we get around this for calculators that don't have that functionality is we do this change the base here. So we can actually rewrite this as common log of 12 over the common log of 2. So there's no base there anymore. We're going to use the common log, the base 10, because we have that capability on just about every calculator out there. So you'd enter this on a calculator, and we're going to get x equals 3.58. Okay, so if I go back to here, and now I've got the value of x that works, and you can see it was a value between 3 and 4 like we predicted. So that's a good sign. So I can say, well, this is actually equal to 2 to the power of 3.58. And again, you could try it out on your calculator. Most of the time, because this is usually a rounded number, if you were to plug that in, you'll get something extremely close to 12, 11.99, 12.01, something like that. But don't be alarmed if you don't get exactly the same number. It's just because we're rounding when we evaluate using the logs. Okay, so that's how you can convert any number into a base of whatever you want. You're going to use this technique. This technique works all the time. These techniques work when the base you're trying to change it was already a power, so it could be rewritten as an integer power. Doesn't always happen, but you can see how we do that. So now we're getting actually into equations. We weren't solving an equation here. We're just rewriting each power as a base 2 power. Okay, so here's a technique. We have a question like this, and we're going to rely on what we were doing up here. Okay, so this says 4 to the power x plus 5 is equal to 64 to the power x, and our goal would be to change both of these into the same base. Okay, now I can look at that. Now what you always try is, can I rewrite the larger base in terms of the smaller base? Can I write 64 as a power of 4? And the answer to that is a yes. So because 64 is 4 cubed, so I can rewrite the base as a power, and then the original exponent is still there. And now we're going to use the power of a power rule. So that's equal to 4 to the x plus 5 is equal to 4 to the power of 3x. Okay, so we've now rewritten this both sides with the same base, and that's good. So now you kind of use some logic here, because you're basically saying, well, I know the left side is equal to the right side. It's given here. I know the bases are the same, so therefore the exponents must be equal to each other. So we're going to just do a little therefore statement, because it doesn't come naturally from here to here as a mathematical step. It's more of a logic statement. So therefore x plus 5 is equal to 3x, and you can see this is just a linear equation now. We subtract x from both sides, we get 2x equals 5, so x equals 2.5. Okay, and again, you could go back, plug in x equal 2.5, evaluate both sides, and you'd see they're, in this case, they should be exactly the same, because I didn't do any rounding at any step here. Okay, last example. Got 4 to the power 2x equals 8 to the power x minus 3. So we try to do the same thing we did here. I take the larger base and I try to rewrite it as the smaller base. So can I write 8 as a power of 4? Unfortunately, I can't. 4 squared is 16, so that's not going to work. So the next thing you try, can I rewrite both of them as a smaller power? And I can see both of these numbers, 4 and 8, are powers of 2. So I'm going to do that. So I'm going to rewrite 4 as 2 squared. And I keep my 2x that was already there. And I can rewrite 8 as 2 cubed with my x minus 3 out here. Okay, now I'm going to do power of a power on both sides. So this will be 2 to the power 4x, because you multiply. Now this one you have to be careful, because I'm multiplying 3 with x minus 3. So it's 3 times x plus 3 times negative 3. So it's 2 to the 3x minus 9. It's almost a good idea to put this in brackets. That might remind you, because a very common mistake from here to here would be 2 to the power 3x minus 3, because you forgot to multiply both of the terms with the 3. Okay, so we're at the point where we were over here. We got this left side equals right side. We got the same base. So therefore the exponents must be equal. So therefore 4x must be equal to 3x minus 9. We subtract 3x from both sides, and that gives us the solution right away. X equals negative 9. And again, you could test that out by just substituting it back into the original equation, checking the left side equals right side. Okay, so that's a pretty basic technique. It should come pretty natural, I think. Just remember your exponent laws, especially the power of a power and product rule, and everything should be good. Okay, so we'll continue on with a couple more lessons on some more complicated techniques for solving exponential and log equations. Okay, have a great day.